Alright, so today we're going to be starting our look into integrals, and it's a bit of a big title today. So we're going to be using identities to simplify integrals of squared trigonometric functions. So what that basically means is we're going to get something like cosine squared. We know that equals something else, an identity, substitute that in and then integrate from there. Okay. So before we start any integration, it's always good to look at the general rules for integration. So I'm not going to run through these, but what I am going to say is that we remember that there's plus c on the end, all right, for an integral. So I would suggest taking these down, making sure they're somewhere in your notes that are prominent you can go back to, because you're going to be referring to these all the time. Okay, so make sure you've got these down and you can access them. So let's have a look at those square identities. So if you get something like sine squared x, it's difficult to integrate unless we change it into its identity form. So sine squared x, we can change it to 1/2 lots of 1 minus cosine 2x, and that's going to give us a constant half and cosine of 2x. Now if we go back to our rules for integration, we can integrate a constant and we can also integrate cosine of 2x. All right, so we can use both of those terms, integrate it, and then work from there. So that's the first one. Next one is cosine squared x, which turns to the same thing, except instead of minus cos 2x, we get plus. And we've also got 1 plus tan squared x equals sec squared x. So there is a bit of a trick with the last one, but we'll have a look at that in terms of an example. So let's have a look at an example now. We want to integrate 1 minus sine x squared with respect to x. Now, the first thing I'm going to do is I can see that we're going to get a sine squared x somewhere. So I'm just going to take note that sine squared x is equal to 1 minus cosine 2x. Okay, I'm just going to put that down before I expand it, because I can see it's coming. If you can't see it coming, that's okay, and we'll expand first, and you could have done this second, but I'm just going to put that down. So what we've got here is 1 minus sine x squared. So we're going to expand using the FOIL method. So firstly, it's going to be, if I write this out, 1 minus sine x times by 1 minus sine x. That's what this squared function is telling us. All right. If I multiply the first terms, I'm going to get 1. Second terms, I'm going to get minus sine x. So first, outer, inner, I'm going to get minus sine x. And then the last terms, I'm going to get minus sine x times minus sine x, which is positive sine squared of x. All right. Now, if I collect like terms, I'm going to get 1, take 2 sine of x. I've got plus sine squared of x, which means I can do plus half 1 take cosine of 2x. All right, which is going to give me 1 take 2 sine x plus a half take 1/2 cosine 2x. And again, I've got some more like terms, so 1 plus a half is 3/2 take 2 sine x minus half cosine 2x. So before I've done any integration, I've just expanded it out, collected like terms, and now we can integrate from here. So yeah, using my integral notation, we've basically been asked to integrate 3/2 minus 2 sine x minus 1/2 cosine 2x with respect to dx. And this is where it's going to come in handy using our rules for integration. So the first one we've got to do is 3 on 2x. That's just a constant. So if we integrate a constant, we're just going to get that constant times x. So we're going to be given, so this is going to equal 3 over 2x. So now we've got minus 2 sine x. So again, using our rules, the integral of sine x is minus cosine. So we're going to get minus 2 cosine x. And a final term is 1/2 cos 2x. So we've got down here, we've got cos something x, which is going to be 1 over that something, sine of the same thing. So what that means is this is going to equal -1/2. That doesn't change. But we're going to divide by the term in front of x, so times by another half. And it's going to change from a cosine to a sine. And this one doesn't change to x. All right, if I just clean this up a little bit, I'm left with 3 over 2x, take 2 cosine x, take 1/4 sine 2x, and all of that is, you also don't forget your plus c value. Okay, so that's our first example. So we just did the sine squared x. The cosine squared x is extremely similar. We're going to skip that one, but we are going to have a look at the tan squared x identity. And we want to integrate 1 plus tan squared x with respect to x. Now, like I said, when we see this, we want to put the shortcut in, all right, or the actual identity. So this one's a little bit different because firstly, there's 2 parts to it. So 1 plus tan squared x equals sec squared x. If I move my 1 to the other side, it also means that tan squared of x equals sec squared of x, subtract 1. So just minus 1 over to the other side. And that's going to be really handy as well in case you just get a tan squared x pop up by itself. All right, so we want to integrate this, and there's a couple of little tricks to it. So here's the integral we've been asked to do, 1 plus tan squared x. And we know we can just use the identity to change that to sec squared of x. Now, I'm just going to grab a different color because this sec squared of x, oops, I should have grabbed the whole thing, sec squared of x, if I jump over here, if you remember, we know that d by dx, if we differentiate tan of x, so you can do this in a minute, but if we differentiate tan of x, it actually equals sec squared of x. So what we can do is we can actually, now we've got this in our integral, substitute in this part because it's the same. All right. That might not look obvious as to why we can do that, but it'll pop out nicely. So if we, again, we rewrite it, we rewrite the integral of, oops, that should have been by dx, d by dx of tan x. We're integrating that to dx. So what you get here is actually you've got 2 of the opposite things. You're differentiating and integrating on the same function, right? So these things are actually the inverse operations and are going to cancel out. And what we're left with is this thing just equals tan of x. All right. Yeah, because we're integrating, we're also just going to put in our plus c. But that's it. So we've got our tan of x plus c and that's the answer. So we took our original, substituting sec squared x, used our knowledge of sec squared x, and yeah, popped out with this answer. So thanks for watching. We'll have a go at a couple now ourselves.